Hello, and welcome to section 9.3, day 1, trig ratios of any angle. So today we're going to talk about drawing terminal angles in standard position, and then we're going to introduce the unit circle. So it tells us that we can let theta be the angle in any standard position. Standard position is always going to be the initial ray, the terminal side, is the x-axis, and wherever this point ends. So notice here's our point, x comma y in the circle. Our radius is the hypotenuse. This is our x distance, this is our y distance. This tells us all of our ratios. If we think of the angle being in close to the origin, which it always will be, notice sine is opposite the y over the r. Cosine is x over r, and tangent's always opposite over adjacent, which is y over x, and our three reciprocals. So the first thing, for example 1 says, let 8, -6 be a point on the terminal side of theta in standard position. So the first thing we're going to do is draw this angle. If we think about 8, -6, that's the point right here. So when we look at this, we always drop the altitude to the x-axis. Here is our r. This point is 8, -6. And we notice here that this is our 8, this is -6, and we have our r there. Remember, theta is close to the origin. So in order to find the 6 trig ratios, we need to start off by finding our r. So we would say -6 squared plus 8 squared equals r squared. We would use Pythagorean theorem, and we'd get 100 equals r squared. We take the square root of each side, so we know for this example our r equals 10. So we know that our 10 is really our r in this case. So now we can go through and find our 6 ratios. The sine of theta is our y, which is -6 over 10, which will simplify to -3/5. Our cosine of theta is our x, which is 8, over our r, which is 10, which will give us 4/5. And the tangent of theta is opposite, which is y, -6 over adjacent, which is x, so that simplifies to -3/4. Now, once we have those three, our reciprocal identities, we're just flipping them. Cosecant is -5/3. Secant of theta is 5/4, and the cotangent of theta is -4/3. Those are our 6 trig ratios. We actually have to draw the angle. When we look at example 1 or example 2 down here, notice we already have the angle drawn for us. We're still going to find the 6 trig ratios, so they're saving us the drawing step. We drop an altitude down to the x-axis. There's our theta. I like to go through and say, well, my x in this case is -8, and my y is 15, and we need to find the r. So we would do -8 squared plus 15 squared equals r squared. -8 squared is 64. 15 squared is 225. 64 plus 225 is 289. And then we would take the square root of that, which is 17. So that is our r in this case. So our r is really 17. Once we have our r, we can now set up our ratios. The sine of theta is opposite, or y, which is 15, over 17. The cosine of theta is -8 over 17. And the tangent of theta is 15 over -8. And I should have just written that as -15 over 8. Once we know our first 3, our second 3, we just flip them because they're the reciprocal identities. So our cosecant 17 over 15, our secant's par's 17 over 15, our secant's -17 over 8, and our cotangent is -8 over 15. Now notice the nice thing about the first two problems we've done is that both of these triangles are Pythagorean triples. So that comes out to nice, neat whole numbers. Okay? So when we look at the second page here, we have one more example like this. We have 3 and -3. So once again, we drop our altitude. Our theta goes near the origin. Our x is 3. Our y is -3. And here's our r. So the first thing you do is find the r. So we'd say 3 squared plus -3 squared equals r squared. 9 plus 9 equals r squared. 18 equals r squared. We take the square root of each side. So the square root of 18 equals r. But we're going to simplify this to be the square root of 9 times the square root of 2. So we'll have 3 square root 2 equals r. Once again, from our previous videos, we should realize that this is a 45, 45, 90, and our hypotenuse is 3 square root of 2, or leg times the square root of 2. If not a big deal, you can still get the answer. So now we go through, we're going to say the sine of theta is our y, which is -3 over 3 square roots 2. Now, right away, I realize that I can make this -1 over the square root of 2, 3 over 3. We rationalize the denominator, so we'll get negative square root 2 over 2. The cosine of theta is the same thing, except now we do our 3 over 3 square root 2, which will be 1 over square root 2. When we rationalize the denominator, we would get the square root of 2 over 2. And then the tangent of theta is going to be our opposite, our y, -3 over 3, which is -1. Once we have all those done, we can now say our cosecant of theta, we're going to flip this one right here, negative square root of 2 really over 1. Our secant of theta is just root 2, and our cotangent of theta is really just still -1. So here's our last bit of information for today's lesson. This is going to be your first introduction to what we call the unit circle. Notice it says a circle of x squared plus y squared equals 1. That's telling us that the x and y coordinates are at the origin. Obviously, center at 0, 0, radius is 1. It's called the unit circle because the radius is always 1. All right, the values in sine and cosine are the y coordinate and the x coordinate, respectively, of the point where the terminal side intersects the unit circle. So just like we had in the beginning, sine is y over r. Well, now that r is 1, sine is just y, cosine is x, and just know that tangent of theta is y over x. Same thing like it was in the front of the page. So what we're going to do for this last part is we're going to talk about quadrantal angles. Quadrantal kind of sounds like quadrant because there's 4 of them. All right, it's a standard position that falls on the axes. Right, these are special cases, and they're all multiples of 90 or pi over 2. 90 in degrees, pi over 2 in radians. So, for example 3, it says use the unit circle, notice unit circle, to evaluate the 6 trig functions of the angle. Well, if we know it's 90 degrees, and I look up at this top part here, that's my point where 90 degrees is. So my x would be 0, my y would be 1, and my radius would be 1. Okay, the radius being 1, it's always 1 with a unit circle, so we're really only going to deal with the x and y values. So sine of theta is just our y, so that's going to be 1. Cosine of theta is our x, which is 0, and tangent of theta is y over x, which is 1 over 0, which is undefined. Okay, just moving forward, I'm not going to write out the whole word. I'm just going to say undef, which stands for undefined. Now our other angles obviously would be cosecant of theta would be 1. Now this is 0 over 1, so when we flip for the secant, it's 1 over 0, so that will also tell us that it's undefined. And then our cotangent, sorry, this isn't going to dry, but just want to kind of get rid of it. The cotangent of theta would be 0 over 1, which is 0. Okay? So, similar to the next one, it says theta is 270. Well, 270 is down here. So now our x is 0. Our y is now negative 1. So sine of theta is now going to be negative 1. Cosine, which is our x, is 0. And tangent again would be 1 over 0, which would tell us that it's undefined. Cosecant of theta, which is negative 1. Secant of theta is 1 over 0, 1 over 0, which is going to tell us it's undefined. And the cotangent of theta is 0 over 1, which is 0. Okay? So that's the lesson for 9.3 day 1. If you have any questions, please let us know. Your homework will post soon. Have a great day. Bye.